Okay, we're working on 4.nf.1 equivalent fractions. Let's work on first one of the ways that I teach students to do equivalent fractions. We first introduce it by using visual fraction models, and then we move into learning how to actually use multiplication and division to create those equivalent fractions. Okay, so if we were going to make an equivalent fraction for, let's say, 1/3, when we first introduce the method, I teach students, okay, well, we want to draw two visual fraction models. We'll just do a couple of rectangles here. Okay, so I want to make them identical to each other first of all. I want to make them, and of course it's the number of equal parts is based on my denominator. Again, this is the denominator right there. That's the denom. And the top of our fraction is our numerator. Okay, we'll just shorten that a bit. Okay, so the number of equal parts, again, is based on whatever our denominator of our fraction is, and we can see that it is 3 in this case. So we want to make sure we do 3 equal parts. So, and based on our numerator, that's typically is designated for how many parts are shaded, we could say. Okay, so if I want to shade some of those parts, I want to shade 1 out of 3 because it's based on our denominator. So I shade 1 here. And I'm going to go ahead and make my second visual fraction model identical by shading 1 out of 3 here. But you're thinking, well, this is even equivalent. They're exactly the same. Well, I'm going to go back and correct that, because now I'm going to come here and I tell students it's so easy to just simply draw a line straight across. And now you have the exact same amount shaded, exact same size model, basically. And then but you have created a varying amount of parts. So we see here we've just shaded 1/3, and here we can see now that we have shaded 2/6. 2 out of 6 equal parts. We doubled the number of parts once we split the box in half by drawing a line straight across the rectangle. Alright, let's try that again with a different fraction. Let's say 2/5. Okay, so again I'm going to draw two basically same size visual fraction models, and I try to encourage students to always stack these up so you can see that they are about the same size, because when it gets to the point where we're comparing fractions to see which fraction is greater or if they're equal or whatever the case may be, if we have them drawn the same size and we have them stacked up, then we can make that model much easier to use to help us judge. Okay, I'm going to split this into 5 equal parts because, again, our denominator tells us how many equal parts of our fraction. So we're going to do 5 equal parts. Okay, so I'm going to make this one look basically like this, the top one. Okay, so I have that. And now I look back at my numerator and it tells me that we're going to shade 2 of the 5 equal parts. So let's go ahead and let's shade this one. And let's shade the second one. And let's go ahead and do the exact same to the one at the bottom. Okay, so now I've shaded 2/5 of this one. But I don't want to leave this one the same because I am making equivalent fractions. So again, I can just go, I can draw a line straight across. And now I have a fraction of 4/10 that are shaded. Okay, so now I have 4 out of 10 are shaded. So we can do that simply by doing visual fraction models. We can see that 1/3 is equivalent to 2/6, and 2/5 is equivalent to 4/10. But then, if as we work through this, we're going to show students, oh, look, if I multiplied the top and the bottom by 2, look what I would create. 1 times 2 is 2, and 3 times 2 is 6. Oh, that's how those two are equivalent. And if I multiplied top and bottom of 2/5 by 2, I make an equivalent fraction 4/10. So this leads us to explain to students that we can use multiplication to make equivalent fractions. We can also use division, but we can use multiplication, but the key is we have to make sure we do the exact same step to the numerator as we do to the denominator, and vice versa. Must do the same to the denominator as we do to the numerator. And so that's exactly how we can create equivalent fractions. Let me just show you a few here with multiplication. We'll do a couple of division as well. Okay, so if we have 2/3. Let's do 2/3. Alright, so I can choose, I tell students that you can choose any number that they want to multiply by to make an equivalent fraction. There's no right or wrong. If they want to choose 100, they can do 100, but they have to make sure if they're drawing a fraction model, they don't want to do that many equal parts. They might want to think that through before they begin choosing what they're going to multiply by to create that equivalent fraction. I'll go with 3 on this one, but I have to make sure when I'm making equivalent fractions, I must do the same to the numerator and denominator, the top and the bottom. So 2/3, let's make an equivalent fraction. 2 times 3 is 6, and 3 times 3 is 9. So now I know that 2/3 is equivalent to 6/9. Okay, and I can do the exact same skill. I can also go the opposite way, and I can do that with division as well. So if I have 4/10 and I want to make an equivalent fraction to 4/10, they have a common factor. 4 and 10 both have a common factor of 2, so I can divide numerator and denominator by the same number, of course, to keep it equivalent. And 4 divided by 2 is 2, and 10 divided by 2 is 5. So now we see that 4/10 is equivalent to 2/5 by dividing numerator and denominator by 2. Hope this lesson has helped you to see how we teach equivalent fractions using visual fraction models as well as multiplication and division.